Hi everyone. Uh, Welcome to our next session on this journey of DevOps and cloud. Okay. Today in our session we are going to learn about few basic terms that we'll be using throughout our journey. Okay. So I thought that would be better that we take a break and we instead of continuing and moving along and learning about the CI/CD and DevOps concept, it's better that we learn few things about the terms and the technologies and the different concepts that we'll be using throughout this journey. Okay. So today in our session, we are just going to learn about few concepts, few terms that we'll be using very frequently throughout this series. Okay. Uh, so first of all, we need to understand what is an application. Okay. What is an application slash software? Okay. Although I told you in the last session that a software is basically some lines of code that have been compiled, right? Uh, some source code that has been compiled to create an executable file, right? So this is the typical definition of what is a software. This is the executable that we use to run or do different tasks, right? So let's say if we talk about Microsoft Word, right? Behind the scenes, Microsoft Word must have been written using some code, right? And when the code was compiled, a set of different binaries .exe files, executable files would have been created. Okay, and these are the executable files which when you click on these are the executable files that open up the Microsoft Word or different applications in your laptop and enables you to work on those. Okay, so these executable files are the ones that actually enable you to make the best use out of the software. Okay, the code by itself is not that effective, right? So what companies generally do, right? They don't share the code with you because that is proprietary. They are not going to share the code with you. Okay. Instead, they create the executable and they provide you the executable, which is just again, I mean, like it's just you can just execute it. You won't be able to see what is the actual content of that. Okay. If you try to double click on any executable file, you try to perform some action. Okay. You will not be able to see the underlying code for that exe. Okay. Now, when we talk about applications and softwares, right, there are two different kinds of applications. Okay. One category is for desktop applications. Okay. And the other is web applications. So when we talk about desktop applications, we are basically referring to applications like Paint, applications like Word, okay, Office applications, PowerPoint, Excel, Paint, right? Adobe Reader, right? So all these are desktop applications because when you click on these, you are able to work on them on your laptop, right? But then there are web applications, right? Like websites like Twitter, Facebook, right? These are your web applications, okay? Now, the way or the methodology to write both these different kinds of application is totally different. Okay, but if you have an expertise in writing one kind of uh, if you have an expertise in writing code for desktop application, you can pretty easily do the same for any web application as well. Okay, the only difference is the web applications need to be hosted so that all the people on the internet are able to use that. Okay, as we go along, like we'll also see how we can host websites and let people use it. Okay, but for now, you just need to understand that the applications can broadly be divided into two categories. One is desktop applications and web applications. Okay, and how are these desktop and web applications created? They have a source code behind it which is compiled, and then you have a binary or an executable file that gets created. Okay, and this is your application. Now, when you double click on the application, right, behind the scenes, okay, it basically creates something called a process. Okay, this process basically talks to the CPU and lets you perform different tasks. Okay, so let's say when I open this application called Smooth Draw, right, it must have created a process. Okay, and when I click on file, it gives an instruction to create a process to do something, and that process tells the CPU to show this menu for the file tab on my screen. Okay, now how we can see these processes and application, where are they running, right? This is something that we should be able to access and see in real time, right? So if you go to your bottom menu and click on the task manager, right, a window something like this will open up. Okay, now if you can see on the top right, you have different tabs. Okay, if you go on the processes, you can see all the processes that are running. Okay, and each of these processes has been spawned by an application that is running on my machine. Okay, so you have OBS Studio, a process that is run by OBS, you have Google Chrome, you have Zoom, right? All these are processes that are doing different talking with the CPU and enabling us to do something else. Okay. I might not be using them actively, but just because they are open somewhere, you can see that in real time they are using some capacity of the CPU and memory and disk and network, right? What is CPU memory? We'll talk in a while. Okay, but for now you get an idea that process, like one application could have multiple processes. Okay, and each process is doing some different task. Okay, so process in short is something is kind like a is a, you can say, an entity or something that performs a fundamental task for your application. Okay, and one application could have multiple processes running for itself. Okay, it could have multiple processes. Okay, now we should be able to see from the task manager which applications are running. So for that you can go to app history, and here you can see all the applications that are running and the consolidated CPU time, network, okay, everything that is being consumed by that application. Okay, then of course you can go to the users and see like how many users are logged in at any point of time and which processes are being used by which user. Okay, for now it's just me that has logged in, so that's why you can see that all the processes that are being run by me, they're consuming 1789 MB of memory. That is almost approximately 80% of the total memory which my machine has. Okay, and then of course you can see all these processes, detailed information of all these processes, as you can see, right? Each of these is an exe file, right? Executable file that is running. For Acrobat, you could have, you can see there are two different processes that are running, right? And who is the user that is running this process? It's of course me, that is logged into the laptop right now. Okay, so that is why you could see that it's me against my name. What is the status right now? How much CPU it is using, how much memory it is using, right? And likewise you could see that there are some processes that are like have been triggered by just one application itself, right? So that is basically a summary of what a process is. Okay, and here you can see, right, each process is assigned a PID. Okay, PID is a unique identity ID that is assigned to each process. Okay, at any point of time, sometimes you might encounter slowness in your machine. Okay, so at that moment you need to go ahead and see like which process is occupying most memory. Okay, and then you need to do an analysis like what is the impact if you delete that process. Okay, all you have to do is just right click on that, and then you need to just go and end task. Okay, if it is a process, it will end the process. Okay, and that will release the CPU and the memory that is being uh, occupied by that process. Okay, and that will like, if you don't want to work on that application, it will just end that application and all the related processes, and then you can move on. Okay, sometimes one application might be creating three or four different processes. Okay, so you have an application, you have different processes that are running, right? Let's say P1, P2, P3, P4. These are different processes that are running. Just to help you understand, if we come here to the detail section, let's say these are the 1, 2, 3, 4, 5, 6, 7, 8, 8 processes that have been triggered by this Acro CEF application. Okay, at any point of time, if I see that, okay, I need some memory, what should I do? I can go ahead and I just come here and I can right click and delete this end task. Okay, and what it will do is it will delete this process and all the related work which the computer is doing for this process. Okay, and as a result of that, almost 5,000 KB of memory will be released. Okay, so that I can do other work. Okay, one thing I would advise is we should not randomly go ahead and delete the processes. We should always be very cautious because there might be some processes that have been started by the system. Okay, that means some processes that are being run by the system to make the Windows work, right? To make our entire platform work. So we should be cautious. We should not just randomly go ahead and start ending the process. Okay, because of that, like sometimes even your system might be crashing because like all of a sudden it might shut down. Okay, because that process might be used for letting you work on your Windows desktop, right, or laptop. So as you can see, some of these are being started by the system. Okay, Now, you get an understanding of what are applications, what are processes, right? What is a software application? What is a web application? Sorry, desktop application and web application. Okay, what are processes? So moving on, the next thing which we need to understand is the difference between what is memory and storage. Okay, so that we don't get confused between these two as we go along. Okay, to understand this, let's take an example of the real world. Okay, let's assume we have a retail shop. Okay, we want to open a retail shop. Okay, and we have two options. One is a shop in core downtown. Okay, and one is at the outskirts of the city. Okay, now if you were to compare this, this core downtown shop is going to be small, expensive, because the real estate prices would be much more. Okay, but it will have heavy footfall. Okay, more number of customers would be visiting the downtown, so we have more chances of selling the stuffs from here. Okay, as compared to that, the shop in the outskirts, right? This can be big. It can be. It will be cheaper, of course. Okay, and then there will be less customers here. Okay, so if I want to have like a small retail shop, of course I will prefer the downtown area. Okay, and if I were to think of a warehouse, right, I would prefer the outskirts, right, where I could have a bigger warehouse, which could be cheaper, where I can store large number of goods. Okay, and then whenever I need those goods, I will just try to transport them from the warehouse to my retail shop, right? So in the same way, right, computer also works. Okay, sometimes or in fact whenever you have any application running, okay, there is some amount of information which the computer needs to store for the proper working of that application. Okay, so let's say for example, right now I have this software smooth draw open, right? As long as I'm working on it, right, there might be few. So we have this application smooth draw. So behind the scenes, it will have few processes that will be running, right? P1, P2. Okay. And these processes, right, they would be carrying some data to and fro between themselves and the CPU. Okay. When I click on this paint, it has some data, loads some data, sends it to the CPU. CPU tells the application to do something, right, and to show something, right, to show the mouse or whatever icon it has. So the application, when it is running, right, needs to have some data almost ready for use, right? So basically, this data should be readily available for the application to be used, right? So what we do is this data, right, will always be stored in the memory, okay, and that will be known as RAM, okay. So this downtown area is going to be, in the computer terminology, is going to be known as RAM. Okay. And this outskirts area, right, will be known as your hard disk. Okay. Why? So let's say if I'm working on a Word document, okay. As long as I'm working on the Word document, I will have some data that is written on it. Okay. I can switch between my Word document and Chrome. Okay. But as long as the Word document is open, right, that Word document data will be loaded into RAM. Okay. And the data will be stored in RAM. Why? Because I, I'm still using that application, and irrespective of whether I'm using Word or Chrome, I need to. So when I use Word, the data for Word will be immediately loaded from RAM, and the data from Chrome will be put down into RAM. Okay. If I click on Chrome, the data from Word will go back, and Chrome will open up, right? So basically, RAM is kind of a substitute that helps us to load the data which we need at that moment of time. Okay. Unfortunately, if you notice, right, we cannot have indefinite amount of data that can be loaded into RAM at any point of time, right? Because this part where we are readily require the data to be available is going to be expensive, right? This is an expensive, like, uh, this is an expensive task that is performed by the computer, right? So this RAM, right, is going to be small, is going to be expensive. Okay, almost the same characteristics as we had we took for the example when we were talking about the retail shop. Okay, it's going to be small, it is going to be expensive. Okay, the footfall, okay, or the in the computer lingo, you can say the number of times this RAM will be interacted by the CPU to load the data and to load it, unload it, right, will be very frequent. Okay, so we need to make sure that only that data that is required very frequently is kept in RAM. Okay, rest all the data we can move into hard disk. Okay, which is not that frequently used. So for example, if I'm working on a Word document, as long as I have it open, the data will be loaded in RAM. Okay, but as soon as I save the data and I close the Word document, immediately RAM will be freed because all the data will then be stored inside the hard disk. Okay, so that's the reason, like, you notice that RAM is pretty expensive. Like 8 GB of RAM would cost almost the same as like 500 GB of hard disk, right? Because of the fact that consuming the data from RAM is much faster as consuming the data from hard disk. Okay. Now, at any point of time, if you are running any application, right, you will be able to go ahead in the task manager again, and you will be able to see which process or which application is consuming which, how much memory, right? So this memory is basically your RAM. Okay, and as you can see, all these applications which are running in real time are consuming the memory from RAM. If I were to close these applications, immediately this storage will move. If there is any storage which needs to be saved, will be stored in your hard disk. Okay, and if you want to see the breakup, you can go to performance and you can see how much memory is being used. Okay, so let's say if you want to have multiple applications running at any point of time, right, you need to make sure that you have sufficient RAM, because any point of time, all these running applications will simultaneously be using your memory from the RAM. Okay, so this is one of the vital things which you need to know of. Okay, RAM should be enough to accommodate or to enable you to run the applications parallelly. If you have just 8 GB and you keep on opening more and more apps, you will notice that at one point of time, your computer becomes unbearably slow. Okay. And if you still continue, eventually it will crash. Okay. Because then it will not even have the storage to even load and unload the data. Okay. To give you an example, let's say if I have Word open, I have Paint open, I have Adobe Reader open, okay, and I have 10 Chrome tabs open, okay. What will happen is all these applications will be consuming the memory from RAM, okay. Eventually, there will come a time that this memory will almost be exhausted. At that point, your application will or your laptop will become almost dead, okay. It will hang, it won't work anymore. To to fix that, you need to go to task manager and you need to ease up or clear or delete these applications so that the uh, memory can be released. Okay, now we know that what is memory and what is hard disk and what is their role. Okay, the next thing we need to understand is what is a server. Okay, because we will be very frequently working with a server. Okay, so you can think of your laptop. Okay, so this is your laptop. Okay, and even this laptop, right, it has some RAM, it has some hard disk for storage. Okay, it has some CPU. Okay, you can run any application here. Even you can even run a website on your laptop. Okay, now this laptop can also act as a server. Okay, so server is anything that basically serves the request that is coming from the end client. Okay, in this case, I am the client and I am trying to use an application that is running on my laptop. Okay, so the laptop becomes a server. Okay, uh, in enterprises, in big companies where you have a lot of applications, very heavy applications that are running, right, you need uh, big servers. Okay, that means they will have not just 8 GB of RAM, they might have 16 GB of RAM. Okay, they might have 2 TB of hard disk. They might have 16 CPUs. Okay, so this is a very normal configuration which which is there for servers that are there in the industry. Okay. Now this laptop of ours, right? It has two aspects. One is the UI part, user interface, and then there is another part that is processing whatever I'm doing on the user interface. Okay. So whatever you see right now on the screen, this is smooth draw and all of this, right? User interface that is allowing me to do drag and drop, click on different icons, right? But whenever I click on something, right, there is a behind the scenes, there is some processing which is which is taking place by the process, right? Which the process is doing. Now, when we talk about enterprises and big companies, right, they have servers that are running inside their own campus. Okay, that would be a data center. Where they will have all their servers running. Okay, now these servers will be like black boxes. Okay, reason being they don't need a UI for us to work on them. Okay, they will be just interconnected with wires. The user interface part will be with me at my home. Okay, so on my laptop, when I open a application called or website for Facebook, this Facebook application is not running on my machine here. Okay, I'm the client. It's not running here. It is running inside a box which is here in the data center that belongs to Facebook. Okay, and what it is happening is there is a network connection that somehow helps me to connect to this data center, send the data to the data center and bring it back. Okay, so when you go to Google or when you go to Facebook or Twitter, any website, right, and when you click on that, that opens a web application, and that web application is running on these servers. Okay, so you don't necessarily need a UI in these cases. Okay, user interface is not required. A graphical user interface is not required for these applications. It is needed, but at our end. Okay, so you could think of server in this case as just this black box. If you attach a monitor to it, it will resemble something like your desktop. Okay, so now that we understand what is a server, okay, now we need to understand like what it takes for us to run an application, okay, or to what does it takes to run a website. Okay, so let's assume this scenario only. We have Facebook. Okay, so Facebook has a data center of its own, and this data center has CPUs, right? So what they did is they took, I'm just giving you a very simple analogy. Okay, so they took an exe file, they started running this exe file here. Okay, and your laptop, when on your laptop you open Chrome or any browser, you go to facebook.com, and you then as soon as you press enter, it basically establishes a connectivity to one of the data center for Facebook. Okay, it sends some information. Okay, whatever, let's say you log in and press login, you enter username and password, and as soon as you press login, it sends your credentials to this server, and the server sends some information back to the client, okay, which is your laptop. Okay, it tells you please use or please show the user this UI page. Okay, and then you are able to see the UI page. Now this, the application is running on this server. Okay, this server access for us is restricted, and we can only interact as a user. Okay, so there are different levels of restrictions that can be imposed by the administrator to allow access to this server. Okay, now this is the server where the application is actually running. Okay, if I were to give you an example, let's assume that I have my own laptop. Okay, in my laptop, if I have to run an application like any exe file, what will I do? I will go to command prompt. Okay, and I will just execute the exe file. Okay, so I will just go to the command prompt, and I will just write whatever ABC or facebook.exe. Okay, as soon as I write that, the application will start running. Okay, and I want you to imagine that there is someone else who is sitting somewhere across the world, and he's trying to connect through to your laptop and use this application. Okay, so from uh, as a developer, right, all you did is you developed the application, you compiled it, and once the exe was ready, you just executed it and the application started running. Okay, now for you, this black screen is like an interface to the server through which you are able to interact with the server, right? Using commands. Okay. In case of these servers, right, you don't have a user interface. The only thing which you need to know is our commands, okay, through which you are able to run the applications and explore the file system. In Windows, you have this mouse, you can go to icons, you can explore the file explorer and everything, right? But with these kinds of servers, you don't get a user interface. So you need to have an expertise over commands to explore or navigate through the file system. Okay. Now, in this scenario, let's assume that I have a file, okay, and I want to run this file. So what will I do? I will open command prompt. I will go here and I will click on that to execute the exe file. Okay. Let me close these. Okay. Now, once this has been executed, right, it's running here, and anyone else across the world will be able to use the website that is running on my laptop. Okay. How it will happen? Let's put a stop to that. So somewhere else, you have your friend here. He will be able to connect through the internet and use the application or use the website that is running on your laptop. Okay. Now, this process, right, where you have a code, you compile the code, you create an executable, okay, and then you copy this executable, go to your server and trigger it and run it, right? This process of copying the executable, right? We know that the process of converting the code into an executable file or a binary file is known as compilation. Now, the process of copying the executable to the server and running it, right, is known as deployment. Okay. So if you were to take this executable file from my laptop, put it on this server, copy it onto this server and run it, right? I would say that I have deployed this application on a server. Okay. So you will come across this term very frequently. Okay. The deployment, what are deployments? So deployment is basically copying of the executable from your machine, okay, and to the server where it will be accessible by the end user. Okay. Um, Now going to back to our previous example, which we talked about in our last session. Okay. Where we saw that there's a business analyst, they send the requirement to the developer develops the code, compiles it, right? And after compilation, this dev will have a server for himself. Okay. And after compiling, so first of all, the developer will develop the code, they will compile the code, and once the compilation is done, they will deploy the code, right? Deployment, again, as I told you, they will deploy means this compiled code, whatever executable has been created, they will copy it onto the server and start it. Okay. This process will be called deployment to the dev server, right? Because the server belongs to the dev team, developers. Now, after testing, the developer will copy and pass on this executable file to the tester, right? Testing team. This testing team will copy the executable or the binary file to the server that belongs to them, right? And this, then we will say that we have deployed the application, okay, on the testing server, okay, test server that belongs to the testing team. And once that all of that is done, and the testing team also gives their go ahead green signal, we will copy this executable file and deploy it on a server that will be used by the clients. Okay. And that we will say that we have deployed the application into production. Okay. So production is a term that we call, that we use when we say that the application has been deployed to a server where it can be used by an uh, actual users, okay, which are our clients. Okay. Now, if we take an example, okay, let's say Facebook has to run, or Facebook initially has to, Facebook is still in the development phase. It has not been created yet. Okay. Mark Zuckerberg is still working on the Facebook application. So the first thing he will do is he will create the code as a developer. Okay. And then he will go and deploy the code on a server. Okay. Once it is running on the server, he will have a testing team with him. He will pass the executable to the testing team, okay, for testing. Now this testing team will copy this executable on their server, right? And they will do all the testing. Once the testing is done and they feel that, okay, now we are good to let all the users across the world use Facebook, they will copy this executable, okay, and they will run this on a server that will belong to production, okay, where people like me, you, everyone can access Facebook. Okay, next time again this is the same cycle that is being going to be followed. Okay, the reason they do this is to make sure that this application has all the necessary requirements, it is not crashing, it is not malfunctioning, okay, before going into production. Okay, because otherwise if once the application goes into production and it starts crashing or starts throwing errors, right, it gives a very brings a very bad reputation and name to the company. Okay, so they need to make sure that the more robust the application is, it's better, right? So they need to make sure that there are no bugs, there are no errors before the application, when the application is being deployed to the production. Okay. Now, each of this server, right, is an environment in its own. Okay. So this server, okay, it's not just one server, right? We call this as an environment. Okay. So environment basically means is a combination of things like a server, okay, and many other things. Okay, we will see what are those things. But you need to understand that when we say environment, that means that we are talking about a server plus the application that is running on the server plus the dependencies that are running on the server, right? And all those things together will constitute your environment. Then you have this testing environment, and then you have this production environment. Okay. Now, one very important thing which someone brought to my attention last time was what are these dependencies? Okay, what are these requirements which these applications requires? Okay, so often you might have noticed that you are trying to install any application on your laptop, right? Let's say you are trying to install Windows Media Player. Okay, when you click on the Windows Media Player, instead of installing, it says cannot install because it requires this softwares, right? These are the softwares that are the dependencies. Okay, these softwares on which my application is dependent for success to run successfully are called dependencies. Likewise, we have these applications that are running on the server also that require some basic programs to run properly. Okay, it could be any program. Okay, or it could be any small binary that might be required. Okay, so this dependencies, right, can be broken down into two parts. One is the software dependencies, the other is the hardware dependencies. Okay, hardware dependencies means that when I'm trying to run my application on a server, right, what do I need on the server as in hardware? I need 2 GB of RAM at least. I need 3 GB of hard disk at least. I need some XYZ amount of like it should be connected to the network. Okay, so all these things will be categorized as hardware dependencies. Okay, then we have software dependencies. Okay, software dependencies like which softwares is my application uh, what my application requires to run successfully. Okay, uh, we will see that, like, but for example, let's say if I have written a Java application, right, one of the most fundamental requirements to run this Java application is that at least my server should have Java installed on that, right? This is one of the most fundamental requirements, right? Likewise, there could be multiple other requirements as well. Okay, so these are the dependencies what we talk about. Now, coming to the life cycle, right, which we saw last in the last session, we have a BA. The BA gives the requirement to the developer. The developer does some coding, and then after doing that coding, the developer does compilation. After the compilation, he will do the deployment to the dev environment. Okay, when we say dev environment, we are basically saying on a dev server, okay, that belongs to the dev team. Okay, then they will do the testing. After the testing is done, they will pass on the executable, okay, to the testing team. The testing team, they don't need to do the compilation now, because after the compilation done by the dev team, they already have an exe with them. This same exe is going to be used by the testing team to do the deployment. Okay, and when they do the deployment, they are going to deploy it to the test environment. Okay, that is a test server that belongs to the testing team. Once that is done, the same executable is going to be passed on to the production team. Okay, so production team is a team that manages the production environment. Okay, and they will do the deployment, that is copy the executable or the binary file to the production environment or prod environment. Okay, so in short form, you can also call the production as prod environment. Now, just like you have dedicated teams for dev environment, the developer takes care of those environment, testing team, the test environment testing team takes care of. So production environment is also a dedicated team that takes care of your application that is running in the production environment. Okay. Now, this entire process, right? As I was telling you in the last session, this process, right, from the starting, when the developer starts coding, and till the time that the application is deployed in the production environment, right? This entire transition, right, is basically we need to understand how we can enhance or how we can expedite this entire process. Okay, let's see why do we need to do that. Okay, there are two companies, okay, two social media companies, S1 and S2. Okay, now S1 and S2 at the starting both have same features in their websites. Okay, now for S1, so let's say after they are they have went live, that is their application is being used by the end users. Now S1 gets a set of few requirements based on the feedback from the users, and S2 also gets a set of requirements. Okay, S1 takes 5 days to develop, do the testing, and do the deployment into production. Okay, S2 on the other hand takes 10 days to do the development, do the testing, and deploy it into production, right? What will happen is after 5 days, they will have these features in the production environment. And again, after 5 days, once it is live, by the time S2 releases this feature, they will again, like, S1 will be one iteration ahead of S2. They will have their own set of new requirements by the time S2 releases these 10 new features, right? So you see, S1 over a period of time, they will have a competitive advantage over S2, right? They will have new features, and users will be having much more like uh, ease in will be much more comfortable working with S1 as compared to S2, right? They will prefer S1 over S2. So that is the reason why companies right now are focusing a lot on making sure that this entire process of development, compilation, deployment to dev, deployment to test, deployment to production, right? How they can expedite it, how they can automate it, right? To make sure that there is least manual intervention here. You don't have to copy the binaries manually from one server to the other server and pass it on to the testing team, right? How all these processes can be automated so that there is least amount of effort or time spent in this entire process. Okay, and then teams can get a competitive advantage over their competitors. Okay, this entire process is something that is managed by a DevOps team. Okay, so DevOps is development plus operations. Okay, so they are not going to only take care of development or making sure that this process becomes faster, right? They also interact with the operations team. Okay, by operations means that those teams that are basically managing this server, right? When you have this server, or you need a team that will be required to, let's say at any point of time, you need more memory, you need more hard disk on your server, you need to install a software, you need to set up a new server, right? In those situations, you will always require an infrastructure, dedicated infrastructure team for to do all these tasks for you, right? DevOps is a combination of, or DevOps is a set of people, a group of people who have expertise in both. Okay, so they know a bit of infrastructure as well as a bit of development. Okay, so that they can create whatever is required to expedite this entire process of development and all the way to release into production. Okay, so that was the summary of DevOps. Okay. Um, if you have any doubts, please feel free to leave it in the comment section. Okay, we'll try to cover those in our next session. Okay. Um, and before that, like one thing I would like to suggest is make sure that you go through all these terms now that you have a like a brief understanding of what is a compilation, what is deployment, right? What is DevOps, what is production, right? Try to go through Google and try to read about these articles so you can get more insight about these. Okay. With that, we'll just try to wrap up this session. We'll catch up again on our next session. Thank you.